Now, when we talked about work energy theorem, we mentioned the word thermal energy. I should be a little more, I should clear up what thermal energy means. Thermal energy is actually molecular energy. It's energy that's associated with molecules and atoms. If you were to look at anything in the universe, if you zoom in on it really closely, you see bonds between atoms in a molecule. Okay, so there's my typical water. Okay, so when I talk about the thermal energy of something, I'm talking about energy that's on a molecular level. Okay, so thermal energy, this idea of thermal energy, hope I spelled it correctly, is kinetic energy, but at a molecule level. Okay, it's kinetic energy so small that it's molecular. Okay, so it's the motion, it's the kinetic energy of molecules. Okay, that's thermal energy. It's molecular motion, or even atomic motion, motion of atoms and molecules. Okay, so when we talk about thermal energy, that's what we're referring to. We're talking about the motion of atoms. Now, don't get thermal energy mixed up with temperature. Those are not the same things. Energy and temperature are related, but they're not the same thing. It turns out that temperature is the average kinetic energy. Okay, so it doesn't mean that because the temperature of an object is 4,000 degrees Celsius that every atom in that, or every molecule, more than likely atoms at 4,000 degrees Celsius, every particle in that system has this kinetic energy. No, it doesn't. It turns out it's kind of an average, and that kinetic energy is expressed in so many different ways. I mean, we can talk about kinetic energy, but kinetic energy is motional energy. It's also vibrational energy. I can have vibrating energies going back and forth there in the bonds. Wah, 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 wah. I can have the object spinning. And all of those are expressions of its kinetic energy. So we talk about thermal energy, we talk about molecular energy as in molecular motional energy, but it's not temperature. Temperature is kind of an average. And how that temperature is being expressed is talking about all those degrees of freedom that an atom has. Okay, so for like monatomic gases, the kinetic energy is something like, I'm calling this off the top of my head, so don't quote me here. I think 3/2 kT. Okay, or is it kT squared? I think it's kT. But like I said, don't quote me. We'll talk about thermal energy and heat cycles and that sort of stuff later, and I'll have the exact number for you, or the exact equation. So when we talk about thermal energy, we're talking about this motional energy on atomic scales, which kind of brings up the topic of phases of matter, because phases of matter is nothing more than looking at the energy inside those particles. Okay, so that's what I'm going to talk about next. I'm going to talk about the phases of matter, and then I'm going to move on. I'm going to talk about heat briefly, and then I'm going to talk about nuclear energy. Okay.